So today we're going to learn about adding rational functions. So we're going to add f of x plus g of x, given that f of x equals 2x divided by x plus 1, and g of x equals negative x divided by x minus 1. So we write the functions f of x plus g of x equals 2x divided by x plus 1 plus negative x divided by x minus 1. Next, we have to find the LCD of the two functions, since they don't have common denominators. To find the LCD, we simply multiply the two prime distinct denominators together to find the LCD. So the LCD is x plus 1 times x minus 1. Next, we have to rewrite the two functions as equivalent functions with the LCD, least common denominator. F of x equals 2x divided by x plus 1 times x minus 1 divided by x minus 1. This gives us 2x times x minus 1 divided by x plus 1 times x minus 1 in the denominator. We can do this since x minus 1 divided by x minus 1 equals 1 for all values except for when x equals 1. Since when x equals 1, x minus 1 divided by x minus 1 is 0 over 0, and 0 over 0 is of course undefined since it's division by 0. Similarly, we can do g of x. So g of x is equal to negative x over x minus 1 times x plus 1 divided by x plus 1. This will, we will obtain negative x times x plus 1 in the numerator divided by x minus 1 times x plus 1. Again, since x plus 1 divided by x plus 1 equals 1 for x not equal to negative 1, we can multiply g of x by x plus 1 divided by x plus 1 without changing the value of g of x. Thus, we have rewritten f of x and g of x with the denominator being the least common denominator, or LCD. So now we have to add the two functions with the LCD. So we need to add f of x plus g of x. So we have to add 2x divided by x minus 1 divided by x plus 1 times x minus 1 plus negative x times x plus 1 divided by x minus 1 times x plus 1. And we get a single fraction. So we add the numerators, keep the same denominator, 2x times x minus 1 plus negative x times x plus 1 in the numerator, and of course the denominator is the LCD, which is x minus 1 times x plus 1. Notice that x plus 1 times x minus 1 is the same as x minus 1 times x plus 1, since it doesn't matter which order we multiply. Next, we have to simplify the fraction by distributing the 2x and the negative x to the binomial, and adding and subtracting the terms in the numerator to simplify. So we have to simplify 2x times x minus 1 plus negative x times x plus 1. So 2x times x minus 1 in the numerator becomes 2x squared minus 2x plus negative x times x gives us negative x squared, and negative x times 1 gives us negative x. So in the numerator we have 2x squared minus 2x minus x squared minus x divided by, this is the denominator, x minus 1 times x plus 1. This is all equal to x squared minus 3x in the numerator, since 2x squared minus x squared gives us x squared, and negative 2x minus x gives us negative 3x. Next, we have to try to factor the numerator and simplify the function if possible. So f of x plus g of x is equal to x squared minus 3x divided by x minus 1 times x plus 1 equals, now we factor the numerator x squared minus 3x by taking the GCF of x out. So the GCF of x squared and negative 3x is x. So factoring that out, the numerator of f of x plus g of x becomes x times x minus 3, and the denominator is, of course, the same. So we see that there are no common factors other than one that are in common between the numerator and denominator of this function. Thus, the function is now in simplest form, and we have completed the problem.